GMAT all day.
In the last few videos, we have been looking at sort of classic standalone ratio questions. So for these last two questions, we'll now look at sort of hybrid ratio questions, or ratio questions where you have to apply your knowledge of ratios in other contexts or combined with other concepts. So I just call this one a word translation, simply because translating your ratio is sort of just one component of this question. It says in 2019, a movie theater showed both classic films and new releases. The price of a new release film ticket is 50% more than a classic film ticket. For the year, what was the ratio of revenue from new releases to classic films? What was the ratio of revenue from new releases to the revenue from classic films? For this question, especially for a question where if you're trying to extract the maximum information from the prompt, but maybe you're unsure how to do that, you're very tempted to look at the statements. The way I always extract maximum information from my prompt data sufficiency is I sort of follow this framework, which a lot of it might sound obvious, but people don't do it. So you can always ask yourself three questions. What is the question asking? Like I said, it sounds obvious. People don't do it. What info do they give me? And what can I do with that info? So I like using this framework, especially when I'm sort of stuck. Sometimes not always the case you can use it. If the question is just saying, what is X? Then you got no choice but to move on to the statements. But if I ever think there's more that I might be missing, I sort of lead on this. So if we start with what is the question asking? So in this case, we got ratio of revenue from new releases to classic films. So I might start by literally writing that out. It's asking me for rev from new releases to the revenue from classic films. So I just need these two things. But I also might note that it seems like they break revenue up into its components because they're talking about price over here. So revenue is really just price times quantity. So this, when they're asking for the revenue of new releases to the revenue of classic films, they're really asking for the price of my new releases times the quantity of new release tickets sold all over the price of my classic films times the number of classic film tickets. So it might seem like we're making this more complicated than it has to be, because we went from having two variables to having four variables. But this is also most likely how they're going to present the information, given that that's how they broke it up here. And so now my goal is, though, I want to get as few variables as possible, because I want things to cancel out so that I just end up with a single number. So they say the price of a new release film ticket is 50% more than a classic film ticket. So that means the price of a new release, it's 50% more, is 1.5 times the price of a classic film ticket. And so here I can cut down on the number of variables I have by just plugging this in. So the price of my new release, instead of being P and R, it's 1.5 the price of a classic film ticket. Everything else is the same. So this is the ratio that I'm looking for. And take note what happens here. So now I have price of my classic film over price of my classic film here. So this just cancels out, and I really just have two variables left. That is the quantity of my new releases over the quantity of my classic films. So I'm looking for 1.5 times the quantity of my new releases over the quantity of my classic film tickets sold. But remember, this is a data sufficiency question. They're going this way. So I can, this 1.5 is sort of just out here, right? Meaning this 1.5 doesn't really matter. I'm looking for 1.5 times Q and R over QCF. Well, in the data sufficiency cuts, I just need Q and R over QCF. So that is how. This is just saying, it's the same as if they were asking for 1.5x. Well, that just means you need x. In this case, x happens to be equal to the quantity of my new release tickets over the quantity of my classic film tickets. And this is my final rephrase, so I can get it all the way down to this. And so look how useful this framework is. Because even though it might seem like we did a lot of work up front, look how much it paid off. They had this question where they are asking about revenue. And revenue is made up of these two components. But then we were able to translate that question so that instead of asking about revenue, it's now just asking about the quantity of my tickets sold. So from this rephrase, because this is a literal rephrase. I know that any information they give me about the price of my tickets does not matter. All I care about is the ratio of my quantities. So perhaps I would start with the second statement here because it looks obviously easier than the first one. The second statement says the price of a classic ticket, the price of a classic film is $10. But that's without even having to plug this in or consider it really even. I can say this is insufficient because it's telling me about price. Price does not matter. All I care about is quantity. And in fact, so this statement here looks like it's not only going to be insufficient, it is going to be irrelevant because I only care about quantity. So unless somehow statement one relates the price in terms of the quantity, you can really sort of eliminate answer choice C as well here. I'll leave it in for now though. Statement one. In the first half of 2019, the ratio of new release tickets to classic tickets was 5-4. Number of tickets sold was 5-4. In the second half of 2019, the ratio was 6-5. So now we have to do a little bit more thinking with this question because here they're giving us what we want, right? They're giving us information about the quantity of the tickets sold, but they break it into two halves. And I think that throws some people off because they think that because we have a first half and a second half, that maybe the number of tickets sold in those two halves has to be the same, or they have to have the same multiplier or something. But no, this is just an arbitrary designation. It's just referring to two different points in time that say nothing about the number of tickets sold during those points in time. We could sell 1 million tickets in the first half and then 1 ticket in the second half. So these two ratios, that means they're entirely unconnected. So we have two different ratios, therefore we need two different multipliers. So in the first half, talking about the ratio of new release to classic tickets, is 5-4 in the first half and 6-5 in the second. So 5x to 4x for the first half, and we'll say our new release to classic film in the second half is 6y, 5y. These ratios, remember, different ratios, they need different multipliers. And in this case, there's no connection between these two ratios. So it is possible that, for example, y is equal to x, but it's not necessarily true. And it most likely is not true. But what do we care about? So we're looking for the total quantity of our new release tickets to the total quantity of our classic film tickets for the year. This breaks up into halves. So if I want my total new release tickets sold for the entire year, well, that's going to be 5x plus 6y. And then my total classic film tickets is 4x plus 5y. And remember, technically we're looking for 1.5 times this, but this 1.5 is irrelevant. So what is our goal? If we go back to that first video, our goal here is if we know we have these two variables, new release tickets and classic film tickets, we want to get everything in terms of a single variable because then that variable should cancel out when we put it as a ratio or as a percentage. But in this case, we can get it down to two variables, but this is really as far as we can go. You cannot cancel out our x or our y. Do not do something like this or this. You're splitting your denominator. If you do that, that is a violation of your fundamental fraction rules. This is really as far as we can go. And so what this is telling us is the value for this ratio is dependent on your values for x and y. And so this is going to be insufficient. And so you can either, if you realize that, say it's insufficient, or you can try plugging in numbers. And as your numbers for x and y change, your value for this ratio should also change. And so this is really as far as you can go, which makes this insufficient. And again, that would eliminate A, but we don't have to really look at these guys together because here, this second statement just told something about price, which is not going to be useful at all in this scenario. And plus the question is only asking for quantity. So you can really sort of eliminate C, and we could have done that before. The answer is E.